Okay, now that we wrote our first macro and we were able to run it a few different ways, now let's talk about variables. And what variables do is they make your sub-procedures and functions, they make them more interesting because they allow you to temporarily store information that you use in modules. When you create a variable, you're going to have to choose a data type. So that's a big point. Every time you create a variable, you have to choose a data type which tells your computer what kind of information your variable can store, what kind of information your variable can hold. For instance, can your variable store numbers, or can it store text, or can it store dates? You have to tell the computer what kind of information your variable can store. And let's start out by just looking at a simple example. So if I create a sub procedure here called sub, I'll call it vars, V-A-R-S, and hit enter, I have a new sub procedure where I can write some code. And I'm just going to get rid of this properties windows now because we don't really need it. So to declare a variable, you need to first write the word dim. This stands for dimension. And then you put the name of the variable. So I'm going to put dim my first variable. Or I'll just put my first I'll put my first variable. And then you put the data type. So this is the name of the variable. This is a keyword that's required. So you write dim and then the name of the variable, and then as, which is a keyword. And then you see this IntelliSense pops up, and it allows you to pick things. I want to declare it as an integer. So I could either use this IntelliSense, or I could just write the word integer, or I could double click this, either way. So this is a variable declaration. Notice that the keywords are in blue, dim is in blue, and as integer is in blue. And what just happened here? Well, I just wrote a line of code that declares a variable, and the dimension of this variable, or the size of it, you can think of dimension as a size, is saying make this variable big enough to store integers. And we'll see exactly how big those are in just 1 second, how big that size is. But this is the general syntax for declaring a variable. If you want to declare more than one variable, you can do this, like dim x as integer. Or you can do something like this. If you don't want to do it on 2 lines, you can do it on the same line by doing x as integer. If you don't want to do it on 2 lines. Notice if you do it on 1 line, you still need the word dim, but then you don't need a dim out here. You separate the variables with commas, and then you put the name of your variable and then the type of the data type. And we'll look at the data types in a second, but what this line does is declare 2 variables. Here's my first variable, and it can store integers. Here's my second variable called x, and it can store an integer too. If you want to now populate your variable with an integer, you can do that by doing something, by assigning it a number. And you assign to a variable like this, my first variable equals, and then you could put 8. And you could also do x equals 80 or something like that. So here I'm declaring variables, and I'll just declare another one down here, dim y as integer, and I'll put y is equal to 6,000. So here I declared 3 variables. Notice you do need the dim keyword, which stands for dimension. I'm going to say this stuff and repeat it because it's important for you to understand these major points. Dimension again means the size, and what determines the size is the data type. And all these variables here, these three variables, have a data type of integer. And that means they can be a certain size, and I'll show you the size in a second. A main point though is that depending on the data type you choose, the size is going to change. So what I did is I inserted a module here. And how did I do that? I just went insert module and I copied in some information. So here's what I copied in. All this information about variables. This is all the data types of different variables. So let's walk through this. First thing we want to talk about is a single line variable declaration, which is what we already saw, right? We already saw that you could do something like this, declare the variables on a single line, or you could declare the variables one line each, right? And if we go to our variables module, this is an example of single line declaration. And all I did is just put some more variables here. Integer 1, dim integer 1 as integer, dim integer 2 as integer, dim integer 3, dim integer 4. Here I have a xDate is the name of a variable that is now of data type date. So you can mix the data types on the same line. And if you want to continue your line, you can put a space underscore that will allow you to continue your variable declaration, your single line variable declaration. So here I have another date variable, and here I have a string variable, xString as string, and I could put another variable here, int 50 as integer. So the point I'm making here is how to do single line declaration. You could do it with one keyword. You need to have the dimension keyword, and then you could put your variable names and their types separated by commas. And if you want to go over the line, if you want to keep doing that, but you're going to run out of space, you can put the space and then underscore and keep doing that. Down here, I want to show you that doing this, dim int 6, dim int 6, int 7, int 8 as integer. This is not the same as this. Notice that the only variable name that has a data type after it is int 8, right? This is a variable name, and here's its data type, which says it can store integers. These don't have a data type after it. What happens in that case? Well, what happens is that integer int 6 and int 7 are going to be by default, they're going to have a data type of variant. And that's what I have in comments over here. I say warning, int 6 and int 7 will be variant, not integer. So don't do this. This is a warning. Do not do this. Make sure all your variables have a data type. And we'll see this more later. And then here's an example of how to assign to a variable again, which we already saw. Okay, so now let's look at a few different things. If you want to declare a variable and you know that the variable's value is not going to change, you can you can use the keyword const, C-O-N-S-T, which stands for constant, and then you put the name of your variable, and then you put the type of your variable, and then you assign it a value. And this means your variable will never change in your code, and you can only assign it once. So notice the const is taking the place of the dim keyword, right? Before we had dim, now we have const. And this is not used too much, but if you have a variable that you know its value is never going to change, you should use const. And this doesn't happen too often, but it's good to know. You should know this. Okay, so now let's look at all the different types of variables. So what we've seen so far are these as integers, and this makes a variable store integers, but there's other types of data types that you can allow on variables. And as I said before, a variable, it's stored in your computer's memory as a certain type, what I call a data type. And there's 10 or so data types, and depending on the data type, the size of that variable is going to change. So we're going to look at all the data types, and I'm going to tell you how big these variables are. So if you declare a variable like this, dim var byte as byte, you're declaring a variable of data type byte. And what does this mean? This means you can store numbers from 0 to 255, and the size of this variable is going to be 1 byte of memory. And notice, what does that mean? This means this is the smallest. As we go down this list, these are the smallest variables at the top, and then as we go down further and further, and I talk, the variables are going to get bigger and bigger. And when I say bigger, I mean they take up more bytes of memory on your computer. So the smallest variable type or data type is the byte, and it only takes up 1 byte of memory, and it can store numbers between 0 and 255. Notice that if I run this code and I try to assign the value 256 to this variable, so if I click run here, I get an error on this line. Did you see that? So let me click run again. I'll put my cursor here. I click run. I get this overflow error because if I click debug, it tells me where there's an error. There's an error on this line because I'm trying to assign 256, the number 256, to a byte variable. But byte variables can only store numbers between 0 and 255. So this is what I mean about it's important to know the data type you're making your variables. Because if you make your variable a byte and you try to assign it a number that it can't hold, it's going to cause an error like this, an overflow error. Now if I assign a number within range, so if I assign it 255, I don't get any errors when I run it. And when I run this, running this code doesn't do anything other than assign this number to this variable. So I don't have any message boxes or anything. All that's happening when I click run is that these variables are declared here, and then this number is put into that variable on your computer's memory. And we'll look in the next video about how to look into your computer's memory. But right now we want to go over these data types. So let's continue. The Boolean data type can only contain true or false. And you could either write the word true or false like this. You could put false here, or you could put true here. Or you could put a non-zero number, which would stand for true, or 0, which would stand for false. So that's how Boolean works. false, you could write the word false literally like this, or you could put 0. They both mean the same thing. If you want this Boolean variable to contain the value true, you can write the word true like that, or you can put anything that's non-zero, like 70. That would mean it contains true as well. But most people write the words out because it's more intuitive. The integer variable data type. The integer data type can store numbers between negative 32,768 and 32,767, and it takes up 2 bytes of memory. Oh, I forgot to tell you, the Boolean variable takes up 2 bytes of memory. So the thing to notice about integer variables is that they don't go up to 1,000,000. And 1,000,000 is an integer, 100,000 is an integer. But in VBA, an integer variable cannot store the value 1,000,000. And I'll try to show you that here. If I put the value 100,000 and I run this, again I get an overflow because integer variables can only store integers up to 32,767 or whatever. And the other thing to note about integer variables is that if you put a decimal in here like 5.6, let's put a message box for this integer variable. So here's my integer variable, var integer. If I run this, this message box is going to display the value. So if I run it, it shows 6. Now I put in 5.6. Why does it show 6? Because, as I put in the comments, implicit rounding will show 6. So integers can only store integers. If you were to try to assign it a rational number, a decimal, anything with decimals, it's going to round it and you're going to get some integer. So beware of that. The currency data type. The currency data type can store very large numbers like this, huge numbers, positive and negative, and they take up 8 bytes of memory. So there's a currency variable here. You can put decimals, they could be very big or very small. The long variable, this data type long, when you declare a variable of type long, it can store not very big. It can store integers that are positive and negative that are very large, and it takes up 4 bytes of memory. The thing to notice about longs and integers, they're sort of the same thing, except that longs can hold larger numbers. So if you're going to be working in Excel VBA, oftentimes you're going to be dealing with row numbers, and an Excel worksheet has 1,000,000 lines in it. So you want to, and those are integers, right? There's no row 5.5 in the Excel worksheet. So whenever you're in Excel, whenever you're doing something with the rows in Excel or columns, you want to use the long variable. And I'll show you this later, but it's just something to think about. Like, if you're going to be working in a worksheet that has 1,000,000 rows, you need to have a variable that can contain the number 1,000,000, and that would be the long variable, right? Because it can contain 2 billion something. Another thing to note about these variables is that what we've gone through so far, I've told you they can store numbers between 0 and 255, or very large, very negative numbers. If you try to put a string into a variable type that stores numbers, you'll get an error like that, like what we just got. It says syntax error because it's trying to put a string into something that can store integers. So you don't want to do that. So I'm showing you some common errors that you need to be aware of. And the main points are: make sure you put a value into your variable that is acceptable. Um, we're almost done here with all the variable data types. So now we're on single. A single data type can store huge numbers, positive and negative. A double data type again can store very, very big negative numbers and very, very big positive numbers, like 4.9 to um, this is like in the many, many hundreds of millions, gazillions or something like that. I mean, these are the biggest. These can store huge numbers, single and double. Double can store bigger than single. That's something to be aware of. How much memory do they take up? 4 bytes of memory for the single and 8 bytes of memory for the double. 8 bytes of memory for the double. And then we have a date data type, and this can store dates from January 1st, 0100 to December 31st, 1999. And date variable types take up 8 bytes of memory. And then we have a string data type. Oh, sorry. To put in a date, you put the date in quotation marks. So if I want to show you this date, I'll just do message box var underscore date. If I run this, there you see my date. It doesn't have the quotation marks, but when I use date variables in Excel, I'm going to be assigning them using the quotation marks. And then we have a string data type that can store 2 billion characters, from 0 to 2 billion characters. And a string data type takes up 10 bytes of memory. So notice, as we go down here, Boolean, integer, currency, long, the amount of space that these variables take up on your computer gets bigger. A Boolean is smaller than a currency. A currency is smaller than a string. Like a currency was 4 or 8 bytes of memory, but a string is 10 bytes of memory. And I'll tell you why we're thinking about that in just one second. Another thing to note, a common error, is like if you try to, let me comment out this string. So now I need to assign it something, and I'm going to assign it a number, like 9. So here I'm trying to assign a number to a string variable, and I'm going to get an error. Actually, no, you won't get a number. This is actually acceptable because numbers are considered, when it says characters here, 9 is considered a character. But notice if I do this, 9 plus 7, and I hit enter, and let me do varstring here. I'll put this in a message box so you can see what's happening here. Is like before we couldn't assign a string to up here we cannot assign a string to a long. You can't put a string into something that can hold numbers. But here, down here, if I hit enter, I get the number 16 because somehow I can put numbers here, and it could go into a string variable, and then I can display that. So that's kind of interesting. You should be aware of that's possible. It's not recommended. If you were going to use a variable that stores numbers, then use a variable type that is related to numbers, whether it's double or integer or long. Don't do this. Don't do addition and multiplication, subtraction with string variables. It's not a good idea. In fact, if you create another string variable like this, like str2 as string, str2 str2 is equal to 100, and then you do str2 minus var string, and you hit run, you get the number 84. But this is, you're doing addition and subtraction with string variables. It just doesn't make sense. Even though VBA allows it, don't do it this way, because people who are looking at your code will think you're crazy. So don't do it this way. If you're going to be doing subtractions and things like that, use data types that are related to numbers. Use long or use double or use integer. Don't do this. So be aware of that. Okay, last one. This is a critical one. There's something called a variant data type, and this can store numbers up to data type double. So basically it's like a double data type, or it can store 1 billion characters. So it's like a variant is like something that can store anything. It can store any, really huge numbers. The biggest numbers you can store are doubles, and it can store almost as much as a string variable. And so that's really flexible, right? It can store numbers or it can store strings, but it takes up the biggest space on your memory. Out of all these different data types, variant is the largest one in size. It takes up 22 bytes plus the length of memory that the string takes up. But 22 bytes, at least 22 bytes it's taking up. Everything else took up like 2 bytes or 4 bytes or 8 bytes. So why is this important? It's important because when you don't declare a variable, say you just have this variable. Let's declare. Excuse me. Let's write a variable name like income is equal to 90. When you do that, income is equal to 90, and you don't use the dim keyword, by default what happens is that this variable is declared in your memory as a variant data type. So that's why it's very critical to declare your variables using the dim keyword. And what can help you do that is this option explicit up here. So at the very top of your module, like we're in this module called variables, at the very top of it, you want to write option explicit. And what this means is that all the variables must be declared. And by declared, I mean use dim or const or whatever. It needs to be declared. You need to explicitly declare your variables. So look at this income variable. I'm not using the keyword dim. So if I go to run this, I get an error and it says variable not defined. That's because I have this line up here, option explicit. And because that line is there, just those two words, it means every variable needs to have the word dim in front of it. If I comment it out like this and then I run it, it works. The code runs and I get that message box down here and everything runs. But the problem is, and this is a critical point, is that this variable was declared variant. Why was it declared variant? Because when you don't declare variables, they automatically are sized to be a variant data type. And remember, why is that important? It's because variant is the biggest 22 bytes. It's the biggest data type. And why is that important? Well, that's important because if you have lots of variables in your code and you don't declare them, you're using up a lot of your computer's memory with these huge variant data types variables. Every variable that you don't declare takes up 22 bytes of memory, and if you have a lot of them, that's going to bog down your memory and slow down your program. If you're running a simulation or doing some calculations and you don't declare any of your variables, they're all going to be very big, and it's going to slow down your computer, because your memory or your computer works faster when it has a lot of memory to do the calculation. So don't slow down your programs by forgetting to declare your variables. And as I said, a great way to prevent that from happening is to use option explicit. So just write option explicit at the top of your module, and this will ensure that something like this, when you go to run it, doesn't happen. It will ensure that you have to declare this variable. So you have to do dim income as double. So now I can store big numbers or small numbers in that income variable, and now when I run it, it works fine. So that is, what we just covered is a lot. You don't need to memorize any of this stuff. You'll get used to dealing with variables. But what's important is that there's, let's see, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. There's 10 different data types for variables. And that's important because, like I said before, you want your programs, your macros, to be as fast as possible. So you want to declare them keeping in mind how big those variables are going to be, and keeping in mind what those variables are going to store. If they can store numbers, then you want to use an integer, a currency, a long or a single, or a double. Just rule of thumb, if you're going to store integers, use long, because they can store integers over 30,000, whereas integer variables can only store integers up to 30,000. So when you want to deal with integers, use long, because they can store bigger integers. When you want to store decimals, use double, because those are the double data type can store the biggest decimal type number. And there are times when you are going to use variant when you don't know whether you're going to get a number or a string back for some reason. But don't use variant too much unless you need to, because once again, they're the biggest variable types. Let's quickly talk about naming conventions for variables. So as we saw with the name of your macro, a variable cannot begin with a number. You'll get an error. So you can't put the name of your variable as a number. You cannot use a keyword as the name of your variable. So if I try to do this, dim sub as integer, I'll get an error because sub is a keyword. If you do dim integer as integer, you'll get an error because integer, it's in blue, it's a keyword. If you do dim as it doesn't know what to do because as is a keyword. Your variable name can't be longer than 250 characters. That's probably, you don't need to worry about that because you're probably never going to name a variable 250 characters like that, right? But you can if you want. And variables can include spaces, so you can do this, like my income as integer. You cannot have spaces with your variable names. The other thing to note about naming conventions is that it's there's a couple different naming conventions out there. One is that every word in your variable name, like my income, the first letter of every word should be capitalized, like this, my income. That's one naming convention. The other another naming convention is to have the first word be all small letters, and then every word after that have the first letter capitalized, like this, my income. And the reason people have these name conventions is that you want your code to be readable. So if you put all your code in small letters, like my income, it's not as readable as this, my income, right? Naming conventions are not critical, but they're something you want to think about, because they make your code more readable to other people, and it just looks better. You know, I try to use naming conventions as much as possible, like to put the first letter capitalized, but oftentimes I don't. Everyone has their faults, right? But in a perfect world, you would always do a naming convention that makes your code more readable. So we covered a lot in this video, and you're gonna have access. You could download this file, and you could look at this variables module, and you could see everything that we just talked about. And we went over a lot of errors, like putting numbers that are outside the range of the variables range. We went over constants. We went over a lot of stuff. So you want to think about these things as you're programming and as you're looking at code. The main things to remember are: always declare your variables, so always put option explicit, because that will prevent you from having programs that are slowed by having large variables that take up a lot of space on your hard drive. A variable is declared using the dim keyword, which stands for dimension, and then there's those data types. The data types are probably the most important thing to take away from the video. You want to be aware of these data types so that when you declare a variable, you want to know, is it going to be a number or a string? And if it's going to be a number, do I do an integer or a long, which can store bigger integers, or a single or double, which can store decimals, or a date, which can store dates, so on and so forth. You want to be using data types that are accurate for the data, for the data that your variable is going to be assigned. So that's it for this video. I know we went over a lot, but it needed to be this long. I apologize for having it this long, but this is one of the most important things. You saw the errors that we encountered, and you're going to see those errors. You're going to forget that bytes only store up to 255, and you're going to put 256, and you're going to get an error. I want you to know why that you got that error. Same thing with putting high in a variable that can store strings. I wanted you to see those errors. So I apologize for making this video longer than it maybe should have been, but it's good to see all the errors. Okay, so in the talk about actually looking at these variables in your computer's memory using the debug toolbar.